video, we're going to discuss how to identify if a number might be an outlier to the data set. Please remember to take good notes. You're going to find that it's going to help you for your test, and you're going to need to upload the pictures of your notes for today's lessons to Google Classroom in order to get full credit. You already know how to make a box and whisker plot. You've done it for us in our class. I am going to go back over the basics of the box and whisker plots and then extend our knowledge a little bit today. The first thing I want you to remember is we're going to start referring to the numbers we find for the box and whisker plot as a 5-number summary. Literally, it has 5 numbers in it. We're going to start by putting the data that's given into ascending order, or small to big, and then these steps you've done for us before. You're going to find your smallest number, find the median, or middle number, also called quartile 2, find your middle number of the data to the left of the median, and do not include the median when you do that. That's called quartile 1. Find the middle number of the data that's on the right side of your median. Remember, don't include the median. This is called quartile 3. And finally, for your 5th number, find the largest number in your data set. I start out with just a very small set of numbers just to illustrate how to do those steps and review on your calculator for you. Step 1 is to put those numbers from small to big. If you needed to do this by hand, you would be finding the middle number of your data set. One quick way to do that is just take off the same amount of numbers from the small side, 1, 2, 3, as you do from the large side, 1, 2, 3, and continue to do that till you arrive at the middle number. That middle number, one more time, can be called quartile 2 or your median. Now, ignore the median and find the middle number of the set on the left side. And remember, if there are 2 numbers in the middle, that you have to average those together. 3 plus 5 is 8. Divide 8 by 2. Quartile 1 number is 4. Now we're going to do the same thing over here on the right side. Ignore the median number itself and take these numbers on the right-hand side and find what's in the middle of these on the right-hand side. And it happens to be 2 numbers again. And you average those. 8 plus 8 is 16. 16 divided by 2 is 8. So those are 3 of the numbers. The minimum, smallest number is 2. Maximum, biggest number, 19. So the 5-number summary for this set of numbers is 2, 4, 6, 8, and 19. I'm going to organize that information for us down here. Minimum is 2. Quartile 1 is 4, the median 6, quartile 3 is 8, and the maximum is 19. I'm also going to review with you how to type those numbers into your calculator in your list and get your calculator to do that stuff for us. So you don't have to worry about putting them in order when you use the calculator, so that's a nice feature. What you do need to remember is you're going to push your stat button, and if there's anything in the, push one more time, enter. If there's anything in your list and you want to clear it out, you have to arrow up to the top until the list itself is highlighted. I'm circling it up here, L1. Then if you push clear and then arrow down, those numbers would disappear. So the clear button is here that I'm circling. You can push down or enter, and those would disappear. I typed them in the list already to save us some time. So that is the numbers on the screen, 357, 588, 62, 19. To get your calculator to find your 5-number summary for you, you're going to push the stat button, then move 1 to the right by using your arrow. And then we do want one variable statistics figured out for this set of information. Make sure you're doing the one variable stat for the correct list. And if there's ever a time where it says the wrong list in there, you push the second button and then choose which one of these you want. Did your numbers go in list 1, list 2, or list 3? And mine are in list 1. Arrow down or push enter 3 times. and your calculator will give you all this information. If you know that the data set isn't sample, you're going to use X bar is 7 for the mean, sample standard deviation 4.95 if you round to 2 decimal places. Or if you think that it's a population, remember you would change that to mu is 7, and you would use this standard deviation, lowercase sigma. But we're most interested in what's underneath here. I'm going to push the down arrow a couple times to get our 5-number summary right here. 2, 4, 6, 8, and 19, just like we found by hand. All right, you guys have also practiced making the actual box and whisker with the 2, 4, 6, 8, and 19. I'm going to copy these numbers and refresh your memory on the actual making of the box and whisker. First, the box and whisker has to have an evenly spaced out number line. It has to have the minimum value on there, 2, and go far enough to get the maximum value, 19, over there on the right. So that's an okay number line to be able to use. The 2, traditionally, we will put a dot at the minimum. We will make 3 vertical bars, 1 at quartile 1, so at 4 vertical bar. At quartile 2, there will be a vertical bar. At quartile 3, there will be a vertical bar. And then at the maximum, you're going to put a dot out here where 19 is. You connect the vertical bars to make your box, and then take each of your dots and connect it to the first vertical bar, and those are called the whiskers. We also talked about skewed left and skewed right. Now, the box itself makes it appear that the mean and the median would be the same number, 6. Because this whisker is much longer on the right side than the left side, this one would be called skewed right. So if we find the mean of the numbers, it should probably be a little bit higher than the median of the numbers. So it would probably be, let's go back and look. Up here on our calculator, we had the median. Notice that the 7 is on the right side of the median because it's skewed to the right. All right, new vocabulary. Make sure to write this one down in your notebook. Interquartile range. We're going to refer to this as IQR moving forward. So when we ask you to find the IQR, the interquartile range, you need this formula. Make sure to highlight it on your paper. All you have to do is find the Q3 number, that's the 8, and the Q1 number, and subtract them, and you have found the IQR, or the how far apart the ends of the boxes are is another way to refer to that. So I'm going to put some work in here. The Q3 number for our data set was 8, and the Q1 number for our data set was 4. The interquartile range is equal to 4. That number in itself is going to be used to help us decide if maybe something might be an outlier of the data set. You will need these two formulas written in red on your in your notebook to refer back to. When we ask you to find if there might be any outliers in the set, we want you to use this formula right here, the Q1 number, subtract, and then multiply 1.5 times the IQ number. And then do it again, new formula, take your Q3 number, add this time 1.5 times that IQR number. So for this data set, the numbers are going to be the Q1 number, the 4 minus, and then 1.5. And our IQ number was also that 4 that we found earlier. And I'm going to go to my calculator. Some of you can even do that in your head. If I do 4 subtract off 1.5, multiply that times the IQR number, the 4, the -2 is going to be considered the lower fence. Then if I do the other one, see if I can write this out here, that number turned out to be -2. Okay, our Q3 number is 8. Add on 1.5 inner quartile ranges. Go back to our calculator here. And I can either backtrack and go get that information and change it to a plus, or just retype everything in. Sit on top of the subtraction sign and change it to a plus. The right fence is going to be called, the number 10 is going to be called the right fence. All right, our book calls those fences -2 and +10. Other resources will just write an interval notation, so bracket here, -2 to 10, meaning that anything on the left side of -2 could be considered an outlier, and anything higher than 10, an outlier. In a picture, we've seen it done this way. -2 would be way over there, and they'll put like a parenthesis type thing to say any number to the left of this green parenthesis looking thing is an outlier, and then 10 is the right fence, so a little parenthesis there. Anything on this side of the right fence is considered an outlier. So in our data set, and we can go backwards and look at that if you want to, the only number that is bigger than 10 is that 19. The only number bigger than 10 is 19. So the number lower than the first number or higher than the second number is considered an outlier. This data set has one outlier, and 19 is that outlier. Please don't assume that you always are going to take out the outliers. It depends on each given situation. If you decide that it's appropriate to take out that number. All right, this data set is much larger, but it's also a realistic set of numbers. I decided to find the grades for every single student in my algebra class and list them below. Let's review. The population mean. Do you remember what symbol we're going to use? Because I said that we had every single student in my algebra class. Hoping that you are remembering, it's called mu, and it's a Greek letter that looks like that. Do you remember what the population standard deviation symbol is going to be? Hopefully, you're remembering it's lowercase sigma. Sometimes it has the little x beside it, and sometimes lowercase sigma just has that little front part. Frequently on quizzes and tests, I'll have you type all the numbers in, and then I'll give you the mean to the data set so that you can check if your numbers are correct. Please pause the video and type all of these numbers into your list one by pushing Stat and then push Enter. Then go up and push Clear to clear anything out of your list. Push down or Enter to see them disappear. Hopefully you've taken the time to type all of those into the list. Once you've typed them into the list, remember type Stat, move one to the right, push Enter, tell the calculator which list you typed your numbers in, and when you push Enter, the new information that should come up on your calculator is the following. So you would know if you got them right. The mean of the data set should be 75.6. The population standard deviation number rounded to 2 decimal places, 16.49. The minimum is 25, quartile 1 is 67, median 77.5, 388, and maximum 100. Remember, you have to use the arrow button to get down to those 5 numbers, the 5-number summary. All right, first thing that I want to do is, can you recall how to find the IQR from our last couple slides? Hopefully you're remembering IQR is defined as the quartile 3 number, 88, subtract the quartile 1 number. You're finding really how much is in between or inside the 3rd quartile and the 1st quartile. When you subtract, you get 21. I want to make sure that you know that when we divide things into quartiles, that means we're dividing it into 4 equal sections. Your numbers will be in 4 equal sections. So after I draw this, we're going to answer a quick question about that as well. All right, here we go. For the minimum number, 25. For the maximum number, way over here at 100. The quartile 1 gets a vertical bar, so approximately here at 67, vertical bar. The median number, 77.5, vertical bar. And the quartile 3 number, approximately right here. Create your box and attach the whiskers to the right side of the box and the left side of the box. If you know that this is all the numbers, you could tell me that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 30 different numbers or 30 students in my class. A quartile means that 1/4 of the students scored in this section, 1/4 of the students scored in this section, and 1/4 here and 1/4 here. So if you have 30 students, N is considered 30. And if you divide that by 4, you get 7.5, which means there's 7 or 8 students in this section between 25 and 67 points on that test. There's 7 or 8 students in this section scoring between 67 and 77.5, and etc. 7 or 8 students here and 7 or 8 students at that high end. Can you recall if this data is skewed or symmetrical? Hopefully you chose skewed. This does have pretty equal boxes, but because the left whisker is way longer than the right whisker, the mean is probably going to be lower than the median. The median's here. The mean is probably lower than 77.5. Quick check. Indeed, it is lower at 75.6. All right. Can you figure out how to see if any of the numbers from those scores might be outliers? Recall the formula for what we're going to call the left fence is going to be Q1 minus 1.5 IQRs. And, let's go ahead and finish that one. So Q1 number is 67, plug it in, put a minus sign, put 1.5, put parentheses, and write your IQ number in the parentheses. If you type that on a calculator and do that math, it's going to be 35.5. And now let's find the fence for the right-hand side. Remember the formula is the Q3 plus sign 1.5 and then the IQR number multiplied by the IQR number. So for this data set, Q3 is 88 plus sign, do 1.5 times the 21. If you do that math on a calculator, we get 119.5. Visually on your box and whisker, you could go to 35.5 and kind of put somewhat of a parenthesis there, and 119 would be around in there, maybe a little farther. So it does appear that there might be 1 or 2 outliers on this left-hand side. Specifically, the interval of numbers that are close in are between 35.5 up to the number 119.5. Anything lower or higher than those 2 numbers need to be thought about carefully to see if maybe we're going to kick them out. So if I go find the numbers that are lower than 35.5, here's one right here. If I figure out that that student was absent a lot because they were sick, that might be a specific reason why I would recalculate my information and not use that number. I don't think there's any other students in here that are lower than 35.5, and we know there are no students up in this top range above 100%. So if there's a specific reason why that student did score that low, it might not be something I want to consider as far as improving my teaching might go, or reporting that information to other teachers. An outlier can be kicked out if you have a specific reason why you shouldn't be putting that number in there. A quick look at three box and whisker plots, just to really drive home the idea that when you look at a box and whisker plot, it's dividing things up into quartiles or quarters. So this group had 24 for n value. And if you divide 24 by 4, that means 6 people fit into each one of these groupings. Notice that this one does look like it might be skewed to the left. And by the way, that's how the outlier shows up in this program. This is actually taken out of my grade book from a couple years ago. And notice that if it's skewed left, that implies that the mean should be left of or lower than the median. And it gives me the 5-number summary when I look in my grade book, and there's that IQR number we talked about today. I think that happens on all 3 of these graphs, but some of the value to box and whiskers and histograms is to try and make a very quick, with a visual, see information. So like people can tell which class had the highest score really quickly. People can tell which class had the lowest score very quickly. You can tell that the median, the lines that are here in the middle, are very much balanced on these 2 classes, but the median for 5th hour a little bit higher than the other classes, type thing. All right, real quick, after all of that, the main goal was, can you figure out the outliers by using the formulas to find the fences? Lower fences, Q1 minus 1.5 IQRs, right fence, Q3 plus 1.5 IQRs. After you find the lower fence and higher fence numbers, check and see if any of the numbers in your data set might be on the low side or the high side. If you find any, consider taking those numbers out and recalculating or redoing your box and whisker without those